All right, we're in unit number 2 still, and we're working through the big three, or actually introducing the big three. And so this one's a big concept. Not only is it called the big three, but it is also a very big concept. I'm going to read this initial paragraph to you, and then we'll derive the big three for you, and then subsequent videos we'll go ahead and do some examples with them. So here it is. In example number 2 of your textbook, in chapter number 2 of your textbook, your authors chose to give you numerous equations designed to solve a specific problem. Deciding which equation to use is the challenge of using your author's approach. And actually, your author that you're using is the same author I had in my first couple classes of physics in college. And I remember when I was trying to read through and solve problems, boy, I got hammered trying to figure out which equation to use in which case, because he had 9, 10, 15 different equations, and I just had a hard time keeping track of all that. So when I began to teach, I felt that let's get rid of all those equations and let's see if we can distill them into 3 simple equations. And I found over the years that instead of using 15 equations, using 3 equations makes life much nicer. And so I call those 3 equations the big three. So from my experience, back on your sheet here, from my experience, choosing the correct equation can be very confusing and difficult. This is using your author's approach. I've chosen to present the same material in a completely different approach. I will give you 3 equations, which I call the big three. These 3 equations can be used to solve nearly every motion problem in this chapter and the next, with the exception of a few minor problems, which I'll help you recognize. So I prefer to give you a few equations and expect you to use them to solve the concepts in the problems that I give you. So below we're going to derive each equation. And what do we mean by derive? Well, in other words, I'll show you where they came from. So we're going to give you the first one. So the first equation comes from the definition of acceleration. I'm going to zoom this in a little bit so we got something to work with. So we talked about acceleration as being a change in velocity divided by time. Now, just as a heads up, from here on out, we're going to pretty much just get rid of these arrows. We're going to assume that you know acceleration is a vector, and every time I write v in these equations, it's going to be velocity and not speed. So you kind of start getting used to that. All right, I'm going to rewrite this a little bit, and I'm going to say this. I'm going to say the acceleration is equal to vf minus vo all over time. All right, so what does that mean? Just kind of thinking here. All right, change is final minus initial. So anytime you hear the word change in position, change in acceleration, change in velocity, change in anything, it's always going to be what you end with minus what you begin with. So it's going to be final minus initial. And then I'm going to take this equation and multiply both sides by t. So I'm going to move the t on the other side. So I get a new equation. I get a times t equals vf minus vo. And then I'm going to add vo to the other side and rearrange it. And I get an equation. I get vf is equal to vo plus at. And there it is. There's our first big three. How about that? How exciting. And if you go to your equation sheet, you're going to find that on your equation sheet. So here's your equation sheet, and I'm going to zoom in just a little bit so you can see it. The big three on your equation sheet look like this. So here's the first one. It's VF equals VO plus AT. And on your equation sheet, I included the arrows on there. When I'm doing freehand, I probably won't include the arrows. All right, so there's the first one. 1 down, 2 to go. All right, the next one, we're going to actually use 2 equations and blend them together. So here's one equation. And I'm going to write them down first, and then we'll talk about them. Okay, there's 2 equations for average speed. I'm sorry, 2 equations for average velocity. They have the arrows, so it'll be velocity. And again, I don't necessarily need to have the arrows on there. I'm just going to put them on there for the first step. So we've talked about this one already. You've seen this equation. Velocity is basically displacement divided by time. That's all it is. You can also do average velocity. This would be velocity here. By calculating average velocity can be calculated in just the way you would figure out a normal average. So if you want to, like, if you took 2 tests and you want to figure out their average, you'd add both of those tests and divide by 2. If you had 3 tests, you'd add all 3 tests and divide by 3. Well, that's what we're doing here. We're just taking the 2 speeds that we have, the beginning and the end, and we just add them up and then divide by 2. So that's average. Now, what we can do is, since both of these are average speed, I can set this piece and this piece equal to each other. So I'm going to say d times t is equal to vf plus vo all divided by 2. And now the rest of it is just algebra. I want to do a lot of manipulating. So I'm going to cross multiply. So 2d equals t times vf plus vo. I'm going to distribute the t. So I get 2d equals vft plus vot. And then pull my thoughts together here real quick. All right, and then we're going to do a substitution. I'm going to go reach back up into my equation that I had earlier, this guy, and I'm going to substitute this guy right there. So 2d stays the same. Instead of writing vf, I'm going to write this. Since there's 2 terms, I need to put a parenthesis on it. There it is. Distribute the t. So 2d is equal to, distribute through, so I get vot plus at, and that's going to be squared because t times t is t squared, and plus vot. Notice I get vot here together, so I can do 2d is equal to 2 vot plus at squared. And then I'm going to divide everybody by 2. So divide by 2, divide by 2, divide by 2. And if I do that, I get d, and here's the equation we want. D is equal to, 2's cancel out, so I get vot plus, and there's a half, at squared, and there's your second big 3. How exciting. And that equation and this equation, let's see if I can show this on the screen, are the 2 things. So the one that's circled here and this equation on your equation sheet are the same. Okay, the last equation, the last one, is a little longer to derive, but we'll definitely take the time and work you through it. We're going to start off with the first of the big 3. And there it is. And then we're going to take the average speed that we had from earlier. So average speed was distance divided by time. We're going to solve this equation for t. And if I solve this equation for t, I get distance divided by average speed. You can work that one out and just verify it on your own if you like. And I'm going to take this and I'm going to plug it in for that t right there. So I get speed, final speed, equals initial speed plus a, and then the t. And the t is going to be d over the average speed. Okay, next one. We're going to recall the average speed was also adding up your speeds divided by 2. And we're going to take this piece and substitute it into that guy there. So we get final speed equals initial speed plus a d, because that's on top, divided by a mess, VO plus VF plus VO all divided by 2. Alright, and then the rest of this is basically algebra, and we just got to work this through. So I'm going to invert and multiply this guy, and at the same time move the VO to the other side. So I'm going to say VF minus VO. So all I did is I moved that VO to the other side, equals, when I invert this one, that 2 shows up in the numerator. So I get 2AD all over VF plus VO. And then, believe it or not, I'm going to multiply VF plus VO to both sides. And it might look like a mess at first, but you're going to find out that this will work out very, very nice for us. So these 2 guys cancel out. I get 2AD, and then I have to do FOIL. So VF squared, and then, let's see, first, outer, which is going to be negative VO, VF. Inner is these guys, VO, VF. That's a plus, by the way. And then the last is going to be negative VO squared. Notice those 2 cancel out. So the last thing to do is to take this guy and move him to the other side, and I get the equation I want. So it'd be VF squared equals, move this guy over, VF squared equals VO squared plus 2AD. And there's the last of the big three, which, if I did it correctly on your equation sheet, should be this guy. And there it is. Same thing. So there is the big three. Congratulations. First big three of your entire physics career.